Alrighty. So we're going to write converting, let's go degrees to radians and vice versa, right? Okay. Do we all know what vice versa means? It's like the other way around, right? Sorry, Patricia, I'll write clear next time, man. Okay. I see him squinting over there. You can't see it. My bad, man. All right. We're going to read this one over here. Can you take it away for us, please? Let's go ahead and go. Pamela, go ahead. Yes, please.
Today we are going to convert degrees to radians and radians to degrees. But before we do that, we need to understand what a degree and a radian is.
Oh, man. And thank God we already have Ariel's cool definition of degree. Does anyone remember what it is without looking at their notes?
Oh, yeah.
Okay, I saw Stephanie's hand first. Go ahead, Stephanie. Very good. A degree is a unit to measure an angle. True? And I just want to add one more important thing here, okay? So this is and normally you wouldn't see this in a definition, but I'm going to put it because it's going to distinguish the definition between a degree and a radian. A degree is not a distance. So note, a degree is not a distance. It's something to use to measure angles, but it's not a distance. A radian, however, is a distance. And of course, over here, we're going to use the same definition for radian. Is that okay? Because it's basically the same thing. All a radian is, it is a unit to measure an angle. And we will investigate why this is not a distance and why this is a distance here. Okay? And now, what is the main difference between a radian and a degree? Jesus, tell us. Question is, what is the main difference between a radian and a degree? Yeah. Very good. A degree is a distance. Oh, is not. Thank you, Jesus, for catching me. Okay? Good job, man. And a radian, what? A radian is a distance. Okay, cool. And now we're almost done here. And then I'll shut up and you guys can take it from here. So, we're going to go ahead and think about this logically, okay? So, we're going to learn a formula, but I would want you to think about where it comes from, okay? It's not magic. It comes from logic. So, a whole circle. Do we agree? Everybody, let's outline the whole circle, because notice, we're going to be creating the radians here. I got a whole circle. John, let me have your attention up here, please, sir, okay? So, a whole circle. How many degrees are in a whole circle? 360 degrees, right? All the way around is 360. So 360 degrees. And how many radians was that?
2 pi.
It was 2 pi radians, okay? And remember, 2 pi is the distance around. This whole thing is 2 pi. Is that clear? You guys see what I did here? 360 around is 2 pi. Is that okay? Okay? Now we're only going to do half a circle, okay? So I'm going to cut the circle in half with the x-axis. Is that cool? Here we go. So now I only want half the circle. So I'm going to outline what I want here. This is my half circle here. Alright. So, question. How many degrees are here now? What is half of 360? 180 degrees. And now think, the whole circle was 2 pi. What is half of that? 1 pi, or just what? Pi. Is that okay? So then this is, so 180 degrees corresponds to what? pi radians. Okay? Now we're going to do a quarter circle. Okay? Now I want you to draw the XY plane here. Why? Because it cuts it in what? Quarters, right? Now I only want a quarter of the circle. Ready? So I'm going to take this slice in the quadrant 1. Okay? Now who can tell me here, a quarter circle, now you can think of this in two ways. You know that a quarter is half of a half, right? Because like half of 50 cents is what? It's a quarter, right? So what is half of 180? 90, but you know this is 90 anyways, right? So this is 90. It's 90 degrees in here, okay? You guys see that? Let me zoom in here. You can see here. That's 90. It looks ugly though. Now, so that's 90. But question, how would I find what is here? Yeah. Half of this was this, so I have to take half of this guy, right? Do we see how that's half? What's half of pi? We're just going to call it, so when you write these, just put it pi. In this case, I divided it by what? 2. Is that cool? So 90 correspond to what? Pi over 2 radians. Okay, good. And we're going to do the last one here for you, and then the rest you're going to figure out. Okay? So 1/6 of a circle. 1/6, so we're going to go ahead and do, let's see here. So we have, let's see here. Let's do this here again. Here. So what is, I don't know, in this one it would be interesting to think about, right? How would I break this up into 6 pieces? You guys see it?
3 pieces first.
Oh yeah, we should have made it into 3, huh? This is a bad idea. The 4-way. Okay? Let me do it again. I'm going to do it down here, okay? You can erase. So should we make it into 3, right? And then what? Yeah, cut it in half, right? Now, if this bothers you, you don't really need this. The point is this, look. I have a 1/6 of a circle, right? How much was a whole circle? How many degrees did a whole circle have? So if I divide that by 6, what does that give me?
60.
What's 330 divided by 6? That's 60, right? So this is 60 degrees. Now, a whole circle was how many radians? So if I divide that by 6, what's that going to give me? 2 pi divided by what? Is what? Pi over what? Pi over 3. Over 3. Okay? So now what we're going to do... Sorry, this is a little messy here. Let me write it again clear. So now what you're going to do over here with your teams is you're going to do the recap over here. Okay? And our goal for this section is I want you to think about a way for you to come up with the formula here. But your first job with your team is to fill in what we've done. There's 2 new ones here. You guys see these at the bottom here? Okay, you're going to have to figure those out with your teams over there. Okay?